Today's topic is about LC oscillations. So first you have to know that what is LC oscillations. So LC oscillation means the electrical oscillations produced by the exchange of energy between the capacitor, which stores electrical energy, and inductor, which stores magnetic energy, are called LC oscillations. Okay, and the electrical circuit containing the inductor and inductor L and capacitor C connected in parallel is called the tank circuit. Okay, this circuit gives rise to the oscillations and is called the LC oscillations. Now I am going to explain with the diagram. So first you see this is a capacitor here and one inductor is connected. So you can remember this one, the energy stored in the capacitor. This is a charge, full charge capacitor. This one is plus and minus. So energy stored in the capacitor is in the form of electrical energy. Okay, now when the capacitor is fully charged and is connected to the inductor, the capacitor will try to discharge. It will discharge through this inductor. Okay, so as it is discharged to the inductor, so what will happen? So there is a current will pass through the inductor, or you can say the current start flowing through the inductor. Okay, as a result of this, the magnetic field is set up around the inductor. Okay, so what will happen in the next picture? So next picture, the capacitor is fully discharged and inductor will be like this. So magnetic field will be produced around the inductor. Okay. So in this time the current will flow in this direction. Now after some time what will happen? Entire energy will come to this inductor. What is the formula of the energy stored in inductor? Half L I square. What is the energy? What is the formula of energy stored in a capacitor? That is Q square by 2C. Okay, that is the thing. Now after that what will happen? This energy again will recharge the capacitor. So the capacitor will become like this. This L, C, and the capacitor will get recharged, but in the polarity will be changed. So you can understand the polarity is changed. And next case, again this capacitor will discharge and will also produce a magnetic field around this one. You can say the capacitor will discharge through this inductor. So in this next picture, the capacitor will again discharge through the inductor. And in this time, the current will be in a opposite direction. That means in this direction, in this way. And also the magnetic field will also produce in the opposite direction, in this direction. Okay, so again in the next picture what will happen? Next case, again this energy will again charge the capacitor, then capacitor will go to the initial condition. So in this, like this. See, L, this one is plus and minus. Okay, so I'll tell you one more time. So first what will happen, like consider the capacitor of this LC circuit, this fully charged. This is capacitor is fully charged, and potential difference across there is a potential difference across this capacitors, and you know that the energy stored in the form of the electric field in the capacitor, that is Q by 2C. Now the capacitor is began to discharge through the inductor, okay, and hence the current start flowing through the inductor, and as a result the magnetic field is set up around the inductor. You can see around the inductor, and when the capacitor is discharged completely, the energy stored in the inductor in the form of the magnetic field, and the formula is half Li square. In the other word, you can say that the electrical energy is completely converted into the magnetic energy in this way. Now, when the magnetic energy is become maximum, when this one is become maximum, the capacitor again began to recharge itself in the opposite direction. You can see in the opposite directions. And now the energy stored in the magnetic field is converted into the energy stored in the electric field of the capacitor. And now again the capacitor is fully recharged, and the whole energy is stored in the electric field in the capacitor. At this time the capacitor again will start to discharge in the opposite directions, okay, and this current flowing in the inductor, and the energy stored in the magnetic field around it. Now again the capacitor will recharge. So this process, the discharge of the capacitor, recharge of the capacitor, this process will happen several times. So and this is known as the oscillations, okay. So you can write down that in this whole process there is exchange of electrical energy and the magnetic energy, okay. So you can write this exchange of energy, this exchange of energy from electrical form to magnetic form gives rise to oscillations called LC oscillations. So this is known as the LC oscillations. Now a question can come in your mind that capacitor is charged and the inductor is getting like energy, and then again it is getting, then capacitor is getting charged. So this process will keep on happen or not? So it will not happen for a long time. So some energy will be lost at the time of discharging and discharging. So it will produce some type of this type of oscillation that is called the damping oscillations. It's called the damping oscillation. Amplitude. This is the amplitude. So amplitude will slowly decrease with the time. Now, if you want to get the constant oscillations, then you have to give the energy. You have to give the energy to the capacitor. So this damping oscillations will get the undamped oscillations. Now question is that what is the frequency, how to find out the frequency of this type of oscillations. So for that there is one little bit there is techniques, but that is not in the syllabus, but you can just give you a little bit hints, so that hints also can help you to find out. So suppose this is your inductor coil and this is the capacitor here, L and C. I current is passing in this way, and plus minus, and then plus minus. So if I use I let the capacitor be charged and connected to an inductor at time t is equal to 0, and after time t, then let the charge of the capacitor be Q, and I is the current in the parallel LC circuits. So now using the Kirchhoff's law, you can use that Q by C is equal to L di by dt, and also you know I is equal to dq by dt. So we put the value here, Q by C plus and minus here actually, so plus L d2q by dt square, sorry dt square is equal to 0, or you can write d2q by dt square plus q by LC is equal to 0. So now this is the equation you can compare with the equation of SHM. So you can write comparing with the equation of SHM, you can write d2x by dt square plus omega square x is equal to 0. So if you solve this one, this differential equation, you'll get omega is equal to 1 by root over LC, or omega is equal to 2 pi nu. You know that nu is equal to 1 by 2 pi root over LC. Okay, so this is the formula of the frequency produced in a LC oscillations. Okay, so what is LC oscillations? LC oscillations means the energy will be stored in the capacitor. This energy will go to the inductor, and after that inductor will get energy, full energy of the capacitor in the form of magnetic energy, and this energy again to recharge the capacitor. So this process will keep on happening. So there will be a flow of current. The direction will change. The current direction will change in this circuit. To and fro it will start to move, and this type of things will produce an oscillations. And this oscillations, as there is L and C are there, so that is why that is called the LC oscillations. Okay, so next topic we are going to discuss about electrical resonance. Okay, thank you very much.